In today's note, we are going to look at factoring special products. So with our special products, there's a couple of quick ways to kind of factor it. Right? So similar to how when we expanded special products, there are some quick ways that we can factor them. So if we want to look at factoring perfect square trinomials, let's just kind of review expanding them. So again, we can expand if we wanted to by using the FOIL method or the rainbow method. First, outside, inside, last. Or we could use kind of the pattern or rule that we came up with. Square the first one, square the last one, multiply the two terms together and then double it. Take the sign, and then that becomes our sign for the second term. So if I try the next one, just using the pattern, 4x squared, 1, and then 2x times 1 is 2x. Double that, we get 4x, and then take the sign and make it negative. And lastly, for the last one, 9x squared, we get 4 at the end. 3x times 2 is 6. Double it, it's 12. So 12x, take the sign, and it's minus. So again, that's just a quick way to expand and simplify these perfect square trinomials. So the quick steps to factoring is, first of all, we have to recognize that they're a perfect square trinomial. So again, we have to recognize that pattern by looking at the first term, making sure that it's squared, looking at the second or the last term, making sure it's a perfect square, and seeing if I multiply those two square roots, will it give me, and then double it, will it give me the middle one? So again, those are the quick steps, but we need to recognize if they're perfect squares first. So if I look at A, 4x squared plus 12x plus 9, if I take the square root of 4x squared, that is a perfect square, I can get 2x. If I take the square root of 9, that gives me 3. And if I do 2 times 2x times 3, I do get 12x. So that means that this trinomial is a perfect square trinomial. So then I can simplify this to the first term, 2x, plus the second one, 3, and squared. So again, we're just checking for that pattern. If I look at the next one, I'll square root the first term, 25x squared. I get 5x. Square root of the second or the last term, I get 4. So they're nice square roots, or they're perfect squares. Now I need to check if I do 2 times 5x times 4. Does that give me the middle number? Well, 5x times 4 is 20, times 2 is 40x. So that is the middle number. I'm not too worried about the sign, because remember, the sign is just going to indicate what the sign between the two terms are. So if I factor this, the first term will be 5x, the last term will be 4, it will be squared, and the sign will be minus because of that minus. And same with the first one, it was plus because of that plus. So again, it's just about recognizing the patterns. Now, the nice thing is, if you don't recognize these patterns and you don't do the quick steps to factor the perfect square, that's fine, because you can still factor it as a complex trinomial, right? So you can still do that kind of modified product and sum method, and then go into decomposition. So that's fine. You can still do it that way. It just may be easier or quicker if you can recognize that it's a perfect square. For C, again, I could look for numbers that, well, let's look. If I can't actually take the square root of a -2. So right off the bat here, I can't solve this as a perfect square trinomial. However, what you want to do always is check to see if you can common factor. And in this case, I can take a common factor of -2 out. So I can take out a common factor of -2, because again, looking at this, I want to make sure that I have my terms, or that my first term is usually positive. In any of their cases, generally that's a nice one to have. So I'm going to factor out a -2. I'm left with x squared minus 12x minus, in this case, 72 minus 36. And now I can check this bracket, or this trinomial in the bracket, to see if it's a perfect square trinomial. In this case, if I take the square root of x squared, I get x. Oh, sorry, that should be a plus 36 because I factored out a negative. Square root of 36 is 6. Now I'm going to check to see if I multiply those two and then double them. Does it give me the middle number? In this case, yes, it does. So this is a perfect square trinomial. So the -2 stays because I've already factored it out. I have my first term x. My last term is 6. It's squared. The sign will be negative because of the negative on the second term. So again, you may have to common factor first, which is fine. So if I look at the next one, let's check to see if there's a common factor. And it looks like there is a common factor of 3. So if I take a common factor of 3 out, I'm left with 4x squared plus 20x plus 25. Now, if you are familiar with what your square numbers are, or what your perfect squares are, right? So 1, 4, 9, 16, and so on, right? Because 1 squared equals 1. 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25. If you know your perfect squares, right, that's a good indicator, or those are the numbers you want to look for to help you indicate if it's a perfect square trinomial. So in this case, I do see a 4 in the first term and a 25 in the second, or in the last term. Those are perfect squares. So right off the bat, if I took the square root of 4x squared, that equals 2x. If I took the square root of 25, that equals 5. Now I just need to do that check as if I double 2x times 5, that does give me 20x, so that is my middle number. So this does work out, or the trinomial in the bracket does work out to be a perfect square trinomial. So I'm going to factor out that 3, or that 3 is already factored out, so that still stays there. My first term is going to be 2x. My second term, or my last term, is going to be 5. It will be squared, and the sign between them will be positive because of that positive. Looking at a difference of squares, again, just as a quick review, let's go through and see what we get. So difference of squares, we square the first term, square the last term, and the sign in between them will always be negative, right? If you wanted to, you could use, again, the FOIL method just to confirm that. But again, if we know the pattern from the past lesson, so it does make it a little bit easier. So 16x squared minus 49. And here we have 9x squared minus 100y squared. So again, you can use the FOIL method, the box method, whatever you wish. It is helpful to recognize the pattern, or to understand the pattern, because that is going to help us when we go into factoring. So the quick steps to factor is we want to find the square root of the first term, find the square root, and find the square root of the second term. One thing to note, they must be nice square roots. So you can't just, if you have two numbers or two terms, you can't just say, oh, I can take the square root of it. It doesn't give me a nice number, but that's fine. It has to be a nice number, right? So they have to be perfect squares. So if we look at the first one, x squared plus minus 9. So right off the bat, it does look like a difference of squares because there's only two terms. They're separated by a negative or a minus, and the two numbers tend to be perfect squares. So square root of x squared is x, square root of 9 is 3. So that means that it's going to go into my two brackets. I'm going to have x minus 3 and x plus 3. So once we find those two numbers, we just have to fill it into that general pattern. that we can see up here that a difference of squares is the two numbers, and then one will be a minus b and one will be a plus b. So if I look at the next one, let's see if I get perfect squares. So square root of 4x squared, square root of 81. You don't have to worry about the sign because remember our difference of squares states that it will be minus in the middle anyways. So you just have to make sure you can take the square root of the number. So 4x squared, square root that, I get 2x. Square root 81, I get 9. So that does work. So this is a difference of squares. So that means I'm going to have two brackets. 2x 1 and 9, 2x and 9, and based off the pattern, one will be minus and one will be plus, right? Because that is that general rule or that form for our difference of squares. C, again, same idea. It is helpful to recognize what those perfect square numbers are. So 25 and 49 are, when I have x squared and y squared, you want to have exponents that are even numbers, so you want to make sure that you have that. So we have 5x squared, or sorry, not 5x squared, 5x. Then we have 7y. So those are perfect squares. So in my two brackets, 5x minus 7y, 5x plus 7y. And you can switch around that minus and that plus, it doesn't really matter. D looks a little bit confusing because we have fractions, but that's okay, because if we just focus on the two parts, again, you're looking for that square root. So the square root of 1/9 w4 x2. Again, like I said, you're looking for even number exponents, which in this case we do. So the square root of 1/9 is 1/3. Square root of w to the power of 4 is w2, and then x. So that is a perfect square, although a different one than we're used to. If we look at the next one, 4 over 25 y squared. So square root of 4 over 25, or you could look at the square root of 4, which is 2, square root of 5, which is 5, y squared, the square root of that is just y. So these are two nice perfect squares, again, albeit a little different. So my first bracket, 1 over 3 w squared x, and we'll say this one, let's say plus instead, so plus the second term, so 2 over 5y. Let me move some of this over. And then my second bracket are going to be the same terms, except there's going to be a minus between them this time. So again, a little bit more confusing because we're dealing with fractions, but again, they are still perfect squares. E, looking at them, it has the general form of a perfect square. However, if you try to take the square root of 12x squared, you will get the x, but the 12 isn't a perfect square root. So right off the bat, this one doesn't really look nice, but what we can do is common factor. So again, we always come across examples where we may have to common factor first, and again, that's something that you should always be looking for. You should be looking for that common factor first, especially if it fits a pattern or looks like a pattern that we're used to, but we can't factor it that way. Chances are that if we can common factor it, it will be able to then be factored further. So in this case, a common factor is 3. So if I take a common factor of 3 out, I get 4x squared minus y to the power of 6. And if I square root each term inside the bracket, square root 4x squared, square root y to the power of 6. These are perfect squares, so I get 2x and y to the power of 3. So I can break this down further. I can break down this bracket into 2 brackets. One will be 2x plus y to the power of 3, and one will be 2x minus y to the power of 3. Right, again, just taking those 2 square roots, making 1 plus and 1 minus. One last example. So 256x to the power of 8 minus 81. Again, we should be able to recognize that 81 is a perfect square of 9. So now we just need to check 256 x to the power of 8, see if that's a perfect square. X to the power of 8 is an even number, so that is good, because that means that the square root of that will be x to the power of 4. Now I just need to check to see if the square root of 256 is a nice number, and in this case it is 16. So these are perfect squares. Again, some numbers we may be used to, like the 81, some we may not be, like the 256. But again, it's just a quick calculation or a quick check to see if it is correct. Oops, don't need to do that. So when we factor it, we're going to get 2 sets of brackets. One bracket will have 16x to the power of 4 plus 9. The other one will be the same 2 numbers, 16x to the power of 4, but minus 9. And that's our factored form. Now, again, these are just patterns or rules for helping us factor these special products. If you wanted to factor them like normal using the product and sum method, you could. Right? So let's just bring one, let's say x squared minus 9. Right? If I know that my trinomial is usually in the general form x squared plus bx plus c, in this case, if I wanted to factor this like a trinomial, my product and sum, I'm looking for 2 numbers that multiply to -9 but add to 0. So in this case, my 2 factors would have to be -3 and +3. So if I go back to my bracket, I have x plus 3, x minus 3. So again, you can factor this as a simple trinomial or as a complex trinomial, depending on which one you look at. However, depending on what numbers we get, as we can see in D and F, that may be really tricky. But if you're confused or if you don't recognize the pattern, you can always refer back to factoring simple trinomials and factoring complex trinomials, and that will work in these cases as well.